Let us look at another example of cost volume profit analysis. The Maxus Motor Company specializes in the manufacturing of small capacity motors. The cost structure of a motor has been given to us. So for manufacturing each motor, the material cost is rupees 50, the labor cost is rupees 80, and the other variable overheads is 75% of labor cost. That means 75% of rupees 80. Now the fixed overheads of the company amount to rupees 2.4 lakhs per annum. So this is the fixed cost per annum, and this is the variable cost per motor. Now the selling price of each motor is rupees 230. So what we are being asked to do is A. Determine the number of motors that have to be manufactured and sold in a year in order to break even. B. How many motors have to be made and sold to make a profit of rupees 1 lakh per year? And C. If the selling price is reduced by rupees 15 each, how many motors have to be sold in order to break even? So let's find out the answers to each of these three questions. So in this example, the information that has been given to us is that the material cost per motor is rupees 50, labor cost is rupees 80, and the variable overhead is 75% of the labor cost. So 75% of the labor cost means 80 multiplied by 0.75, because 80 is the labor cost and 0.75 indicates 75%. So 8 5s are 40, 4 carryover, 7 8s are 56, plus 4 is 60, and one more 0 of 80, and then there is a decimal at two places, so 60.00 rupee. The fixed cost is 2.4 lakhs per annum, that is per year, and selling price is rupees 230 per motor. This is also per motor. Now first we have to find out the number of motors to be manufactured and sold in a year to break even. So number of motors to be manufactured and sold in a year to break even. Now we know that break even point is achieved when the total revenue is equal to the total cost. Total revenue is nothing but the number of units sold, which is Q, multiplied by the unit selling price, which is P. Total cost is the addition of the fixed cost and the variable cost. So Q multiplied P is equal to F plus, now the variable cost can be expressed as the number of units sold multiplied by the unit variable cost. So let's bring the expressions with Q on one side, because that is what we have to find and Q is the variable. So Q multiplied by P minus Q multiplied by C is equal to F, or Q multiplied by P minus C is equal to F, or Q is equal to F divided by P minus C. So in our case, F is 2.4 lakhs, P is 230, and C is equal to 50 plus 80 plus 60, which is equal to 6 plus 8 is 14 plus 5 is 19, so 190 rupees. So Q is equal to F, which is 240000 divided by P, which is 230 minus 190. So this is equal to 240000 divided by 230 minus 190, which is 40. 10 we can cancel. 6 4s are 24, so 6 and then 3 zeros. So the break even point in terms of units is equal to 6000 motors. So in other terms, the number of motors to be manufactured and sold in a year in order to break even is 6000 motors. Now let's move to the next one, which is we have to find out the number of motors to be made and sold in order to make a profit of rupees 1 lakh per year. So this was the case where we wanted to find out the number of motors to be manufactured and sold in order to have a no profit, no loss. Now we want to find out the number of motors to be manufactured and sold in order to make a profit of 1 lakh per year. So B is find out the number of motors to be manufactured and sold in order to make a profit of rupees 1 lakh per year. Now profit is equal to the total revenue minus the total cost, or profit is equal to, so total revenue is nothing but the number of units sold multiplied by the unit selling price, and total cost is equal to the fixed cost plus the variable cost, which is nothing but the multiplication of the number of units sold and the unit variable cost. Now let's substitute the values. So profit that is required is 1 lakh. Q is what we want to find out. Multiply by P, which is 230, minus F, which is 2.4 lakhs. Q is the variable, multiplied by C, which is 50 plus 80 plus 60, which is 190, or 1 lakh is equal to 230Q minus 2.4 lakhs minus, we have opened the bracket, so minus and plus is minus 190Q. So now let's bring the expressions with the variable Q on one side and all the others with the numbers only on the other side. So we'll bring this 2.4 lakhs on the other side. So 1 lakh plus 2.4 lakhs is equal to, so 230Q minus 190Q, which is 40Q, or so this becomes 3.4 lakhs is equal to 40Q, or Q is equal to 3.4 lakhs divided by 40. So let's divide both numerator and denominator by 4. So 4 ones are 4, 4 8s are 32, 2 carry over, 4 5s are 20, and then 2 zeros. So this is equal to 8,500 motors. So if Maxus Motor Company manufactures 8,500 motors per year, then they'll make a profit of 1 lakh per year. Now remember, in the previous step we had come up with a number of 6,000 to break even. So they need to manufacture 6,000 motors in order to be at a no profit no loss situation, and they have to manufacture 8,500 motors in order to make a profit of 1 lakh. Now let's move to the third case, which is that if the selling price is reduced by 15 rupees each, then how many motors have to be sold in order to break even? So C is that if the selling price is reduced by rupees 15 each, then how many motors have to be sold to break even? So in this case, we are reducing the selling price by rupees 15 each, but the variable cost per motor is not reducing. So what that means is that the amount which is contributing towards recovering the fixed cost has reduced per motor. So what this indicates is that we'll have to manufacture more than the 6,000 units that we had achieved in step number A. Now let's find out how many more do we need to manufacture in order to break even. So in step number A, we had arrived at the formula for break-even point, which is break-even point for units is equal to the fixed cost divided by unit selling price minus the unit variable cost. Fixed cost is the same, 2.4 lakhs. Unit selling price is now 230 minus 15, which is 215, and the unit variable cost is the same, which is 50 plus 80 plus 60, which is 190. So this is equal to 2.4 lakhs divided by 215 minus 190 is 25. So this is equal to, so let's divide both these numbers by 5. So 5 5s are 25, 5 4s are 20, 4 carry over, 5 8s are 40, and then 3 zeros. Again let's divide by 5. So 5 1s are 5, 5 9s are 45, 3 carry over, 5 6 are 30, and 2 zeros. So 9,600 motors need to be manufactured and sold per year in order to break even if our selling price is reduced by 15 rupees each.